Welcome everybody to our today's pop-up session, Recipe Transfer. So today we're going to talk about the possibilities and of course also the challenges that we have when we transfer a recipe from one machine to the other. And of course I do have a team with me that is helping out, because usually when I look at this is just in terms of color, in terms of time, in terms of how do I use my roast graph and what do I have to do. But today we're going to talk a little bit more in terms of physics and math. And therefore I do have a team with me, and we're going to have a Teams meeting today, as one of our team partners here is not in Emmerich with us, but is sharing us with a Teams meeting. This is Wolfram, so please warm welcome to Wolfram. He's with Backyard Coffee and he's going to say a few words about himself. And of course we have Sebastian again. You remember him from the last pop-up session, and we do hope that you enjoyed this session as much as we did last time. And I will do the questioning part, because I guess I will have some questions myself here. But now let's get started and have a short introduction from Wolfram to his person. Okay, so Wolfram, please let us know who you are.
Welcome everyone. Nice that you're here. Nice that you have me sharing some ideas we were working on for the last 12 years. I'm the founder of Backyard Coffee. We are a coffee roastery located in Frankfurt, Germany. From our history, we stemmed from taking part in barista championships. So this is where we started originally everything. Developing roast profiles back then was a big issue for us, just to develop the perfect coffee for a barista championship. So, and when you grow roastery, we got into a point where we couldn't do it the way we did it for the barista championship, where we did everything just to get the best coffee. And if we have waste and wasted a lot of green coffee for this, didn't bother us at all. But if you start a business, it becomes an issue, and today even more with the rising coffee prices. I'm one of the coffee nerds at Backyard Coffee, and I'm happy to share later what we do, how we transfer profiles from one machine to the other. We're working on this for quite a while now. Okay.
Awesome. Maybe I say like 2 words about myself. I was in the last session, so if you want to hear more about me, just look it up there. I'm a research fellow here at Research and Innovation. I'm doing math in a most general way, like stream simulations and thermodynamics. And I think first we should talk about why is it hard to transfer recipes between roasters. And well, obviously the biggest problem is that roasters are different, very, very different. And their airflow and their heat transfer is very, very different. Last time we talked a little about operating points, and I presented that in the last session. So we're just going to skip over it now, and I'm going to show you some graphs now. So what we want to do first is what happens if everything is the same. So this is, whoops, should have been a 10. So you have your fan curve and you have your roaster curve, which is basically the entire pressure loss your roaster has and the pressure your fan can. Okay, I'm going to share it again. Hope that it works this time. So can you see it again now? Well, anyways, there's a roast curve, which is normally which can be influenced by some sort of flap or bigger roasters, also by your fan. Can you see it again now? Cannot. Okay. Well,
some technical issues.
Well, maybe then I talk just in general about it. So there's airflow which goes through your roaster, and it's going to be different depending on the type of roaster which you have. Because your fan is going to be different and your flaps are going to be set to different values. So if you have two roasters and you put them side by side, it might be the same, but it doesn't have to. And another problem which we have is the thermocouples. I have a presentation here, but apparently it's not coming through right now. Maybe you can see it on the big screen. Okay, let's try that then. So for the thermocouples, they measure a combination of the bean temperature and the hot air temperature, which is not, which is going to be very much influenced by the position of the thermocouple. So if you try to transfer one roast profile to maybe even the same roaster, it's going to be not the same, because the thermocouples, even if they're just off by a couple of millimeters, it's going to become very problematic to get the same results. And that's why it's very difficult to transfer recipes between roasters, even if the roasters themselves are the same, because if chimneys are different, or the room is different, or the climate is different. That's all things they're gonna influence it.
Yeah, that's actually what we experience with the new series of P roasters compared to the PROBAT toner roasters. We changed the position of the thermocouple, and now all of a sudden we get different values, even though inside we do have the same. And then, of course, it's getting hard to say, okay, it has been the starting temperature with my old machine, and it will not be the same with the new one. It will, but it looks different just on the display. So, yeah.
Exactly. And one solution around this would be an infrared thermometer, like a pyroscope. Those are better because they only see the surface temperature of the bean. But then you still have the problem that if you put this back into a control system, you can only control either the temperature or the airflow, and you have no way of switching those values around.
Okay.
Because the way controllers work, either you have a very, very sophisticated controller, or it's going to be very difficult. And the solution for this is to think about, what do you actually want to control? Because you don't want to control, so why do you want to control airflow and temperature? And that will be because at the core of it, you want to control the heat transfer. And to get there, you have the supply gas as a meta medium, which carries temperature and mass flow rate, which then are going to be controlled by burner, power, fan speed, and flap positions. And you need a way to control those three parameters in a way that your recipe will be transferred to your roasters, that you're going to have not the same roasting profiles in terms of temperature curves, because they might look different because of the positioning and such. But you want to have the same result. You want to have the same taste. You want to have the same color, the same moisture, and all that good stuff.
Yeah.
And the way to do this is by looking at the energy which is transferred. So how we want to transfer between roasters is we transfer the specific heat input into a bean from one roaster to another. Obviously, this is very, very much math involved. It's something that's not yet available, because it's like the front of what we're doing right now. It's been tested only minorly because we just finished the models for it. You can see now some sort of simulation, and what you then get is the heat flux to coffee beans. And I don't know if you can see it online, but on the bottom right, there's a graph which has solid lines on it. Those are lines of the same energy input to the coffee bean. And on the left, there's the air velocity. And on the bottom, there's the temperature difference, which is shown. And those solid lines transfer the same amount of energy to the coffee bean. So as long as you have a combination of velocity and temperature, which stays on this line, you're going to transfer the same amount of energy, which transfers to different roaster types. If you have a roaster that's probably maybe better in putting out more heat, but doesn't have as much of a range for velocity, you can go along this line and still get the same result. Maybe have more air, less temperature. So that's a way you can influence this.
Yeah, but then this would mean, in my way of thinking of what people standing in front of a roaster are doing now, even though they have different manufacturers, different sizes, different ages of machine. In most cases, they ask the other roast masters, so what is your temperature when reaching this and that point? What is your temperature when and actually what you're saying now is that the roasting curve itself does not really have that much impact when we probably also compare different roasting systems. But yeah, the energy intake and how the bean actually uses that energy and comes to that certain point where it has that point in aroma. This is much more important.
Exactly. So I'm not saying the temperature curve is not important. I'm saying it's the most important tool you have for your roasting machine.
Yeah.
It's going to be the only thing you have to judge your coffee beans by. But if you transfer your recipe to another roaster, you lose basically all your experience because this machine is going to work entirely different.
Exactly.
And to transfer those points between machines, you get extremely lucky if it works.
Yeah.
Normally, it shouldn't.
Yeah.
And that's why we want to go to a variable which is independent of all those variables, and then is the energy transfer.
Mm-hmm.
So if we look back at this graph again, so we talked about temperature and mass flow rate and how we need to exchange them between the two to stay on an isocline on a line of same values. But then you still have the problem of fan speed and flap positions because you have 3 actuators and you just have 2 variables you want to control. So you again need some sort of modeling to find out how that works. And for that, again, we created a model. And again, you have those lines of the same output. If you work, there's always a position. If you change your flap a little bit and also your fan a little bit, you're going to stay at the same level of operating point. We modeled all those. We call it a roaster state, roaster flow state. What is your roaster working in at every given position? And it's going to be unique for every single roaster in the world. There are going to be very few where this is the same. Let's say you have a roaster standing in maybe Vietnam where it's very, very hot and humid. Mm-hmm. It's going to influence the way your roaster reacts, and you need to take this into account. But to be able to influence this is at the core of what we need to find out and how we want to transfer recipes, because we need to know this about your roaster, and once we do, we can transfer recipes between any roaster.
This is what I wanted to say. This is not anything a roast master who's roasting today can actually do by himself, right? When he's talking to a friend roast master and he gives him his numbers, he cannot just go to some sort of diagram and say, okay, I just put in your numbers and then I know what to do at my machine, because this just sounds so much more complicated and complex.
Yeah, and what we're working on right now is to make it very simple for the roast master to just transfer his recipe to a level where we can transfer them between the roasters and nobody has a problem. So that's what we're working on right now.
Okay, cool.
So just for the fun of it, I'm going to show you what that looks like then. This is...
you said fun. This is not fun.
Well, basically what we're going to do now is we're going to do like a 6-minute roast in a couple of seconds.
Okay.
And it looks like this then. I don't know if anybody of you is familiar with this. This is roasted on an RT3SY, which is a tangential laboratory roaster we have here. It's not a drum roaster, so if you think the temperatures are above what you would think is right, yeah, probably it's just a roaster that works entirely different than what you're used to. Yeah. Gonna try to reshare this. Right. And you see at the top right, I hope you online can see it too. You see those temperature curves, and on the bottom you see those are the values we measured. That's the same everybody would see.
Okay.
And on the bottom you see the energy curves. If you're wondering why the blue curve just plummets,
yeah, it just drops.
That's water evaporating.
Oh, okay.
That's what what you invest most of your energy in.
Yeah.
Just get the air out, and after that, it's just a lot of energy out the chimney.
Yeah, true. Wow.
Yeah, and once you have those curves at the bottom right, and you have the two curves I showed before, one is universal. The first one I showed is universal. Doesn't matter which roaster you have. It's unique to the coffee bean. The second one is going to be unique to your coffee roaster. So we need to profile this for your coffee roaster, which we can do while you just roast different coffees. We can profile it, and then you can transfer. That's the gist of what we're working on at the moment.
Yeah, that sounds much more complicated than of how I do it. I said last time also a lot of what I do when transferring recipes is kind of a gut feeling. What's the aroma in the bean, and how do I think I get there with a shorter or longer roasting, and to make it a little bit more acidic, a little bit more bitter, a little bit more whatever. And this is just really different from how I do things. But also on the other hand, I think it's very important to show that there is a lot more to recipe transfer besides only knowing a certain amount of temperature points, because this is what a lot of people do today. They talk to a lot of people, they read a lot of books, and then they think, oh yeah, I'm going to take this recipe from Roastmaster XYZ, and they just try to do the same on their machine, which is of course not possible to work at anyway, because the machine will be completely different. And most of the times they don't even know what machine the person was using they're taking the recipe from. And then at the end, they're wondering why the coffee is not tasting good, because this person has said, this is amazing and it's a good recipe, and it's just not working. So
it's probably a very great recipe for that particular machine.
With this coffee and those conditions and all of that stuff. Yeah.
Exactly.
Yeah.
So
cool.
What we talked about this far is the very academic, mathematical approach to transferring a recipe. And luckily, we have somebody else here who has a more experience-based approach to everything. And so, Wolfram, do you want to share with us how you're doing it? Because I think that's a great way to lead over to how you can do it in practice without investing 6 years and a PhD.
Yes, for sure. Maybe just a quick recap why we did it the way. So when we started roasting, we were just, the only approach was to develop to get the most out of a given coffee for barista championships. That's what we were aiming for, just to compete and provide the best coffee. So back then it was a 6 kilo roaster, so we didn't care much about batch sizes. So we were having a lot of trial and error, and we're roasting a lot of coffees and just bringing each coffee to the peak. So this is where we started. We didn't care. Then we competed. We're pretty successful back then. And at some point, everything turned to become a real business. So we started the Roastery Backyard Coffee. And if you start this, we just wanted to keep the quality level we had, but now we had a different topic to tackle. It was just we have bigger batch sizes, and we couldn't develop roast profiles the way we did before, because if we have so much waste roasting over and over again, it was an issue, because it's just pure costs, and the coffees we use are rare coffee, specialty, and above. So the green coffee was expensive even back then, and today is even more. So we needed to find a solution for this. And back then, the first sample roasters came on the market that allowed reproducible roast profiles in a small scale. And the idea was just to re-engineer the profiles we had on the big machine, on the 6 kilo, 5 kilo roasters back then, on the small scale, and just reproduce it. So we did a re-engineering of the profiles. And we were doing a lot of trial and error on the small scale. And when we got close, we started sending in the samples into the laboratory to get a chemical analysis of the compounds in each roast. So the big machine and the small sample roaster. And this is where everything started. Back then, everything was very time consuming, because one cycle of sending samples in, getting the results was 4-6 weeks. So it took a lot of time. And this was like 10, 11 years ago. So from there, but the main idea, because everyone always says it's not possible to bring something from a small scale to the big scale. And this is what usually amazes us, because we just say, okay, we want to do it we don't care, we do it. We just go for it, and we think it's possible, and we'll find a way. So the approach we came up with, I just want to give you, I can't explain it in depth, but I can give you a quick overview of what we do today, because what we do is just we develop on an e-cover. Right now, we are just transferring to use the PROBAT sample roaster as well, and we transferred to larger scale roasters for production, like the P12 we have from PROBAT. So let me just show you what we do. So the main aim is just to have a small amount of green coffee, like 100 gram sample. Do you see the
Yeah, we see it.
Okay, perfect. Like 100 gram sample, and you can just
short interruption from technical side, sorry.
Yeah.
We don't see the screen. Something is not going right. You're still sharing your screen, Sebastian. Okay. Now everybody should see it.
Can you share, Wolfgang?
Okay. It should be fine.
Okay.
Yeah, whatever I can share, I can switch between me and this, and you can also have me on top. This is what I can do. Okay, so you have it. Okay, so we want to have like 100 gram sample and want to develop a profile, and this sample should be able to go from this stage to the production stages that you might have. So you scale it up from like 100 gram to 12 kilo or 25 kilo roasters, which would be ideal. So what we are doing, we're looking for is always, we have two different kind of batch sizes we use on each machine. It's either a half batch or a full batch, depending on the machine, because you never know, especially for very expensive coffees, you might not always have like 25 kilos that you want to roast, but you want to have the same result even on a smaller batch. So what we're aiming for is the overall product quality. This is the main reason why we started all of this back for the barista competitions. For today, it becomes more of an issue because green coffees are getting more and more expensive, and it's more vital to get the most out of the beans you have. Many roasters, if they're honest and open, if you get a new coffee from a certain region, like an Ethiopian coffee, you usually drop it in your roaster and roast it the way you did all the roasts before. From there, you do some small adaptations and try to optimize the profile you have. Rarely you do a complete new roast profile or start from scratch. And this sometimes, or many times, depending on the kind of coffees you use, you miss out characteristics the coffee has. And we just always want to find those characteristics. We want to see all of them. We want to be able to develop a coffee from enzymatic over sugar browning to dry distillation stages and get a good overview of what the coffee has to offer. And then we decide how we want to use or roast the coffee on the production scale. And we can do this because we only waste like 100 grams on the small scale on the sample roaster, and then we are able to bring it over to the production machine. Okay, so what do we do? So just to get everything running, let me just take this out. Okay, so if you just have a regular roast profile, that's just an example of any curve, so it's not correct by any means. But what you usually have is, if you go for this, you're looking for a certain spot. So what do we do to be able to transfer it? So we measure certain things or collect data of the coffees we roast. So what's important to us is the color, the solubility, and sensory attributes. These are parts of what we collect. Based on the values we have, we calculate stuff. So it's even there, we can't go without math, because actually there's a friend for you. So we calculate something that's a solubility index, and we calculate something, we name it development index, which also, so the solubility index is only looking at the core values that can be read by measurements, and the development index also has sensory attributes as well. So we do a cupping with a team, and they give feedback, and those values go into the calculation as well, just to see how well the coffee has developed. And we collect all of this data, which you can see by example here, and then the little table you see below. But we're not looking to get a start point. So the main question is, how do we get from one roaster to the other machine. So it's not just like collecting data. We need something to relate on both sides. So what we came up with is something we call the central balance point. It's the point in the roaster. So every roaster has several of these, but they're very closely related. So there's one point where you get the most solubility out of a bean by the lightest color, and this is a point we are looking for. So you roast the coffee, and it should be as light as possible based on the average color of the bean after grinding, but should have the highest solubility. This means you found the spot where the coffee is most evenly roasted throughout the bean. So this is something we are doing, and let me show you what this means. So if I just continue this here, you see the process that we are just looking for this spot by first defining the amount of energy that has to be loaded into the roaster. So many times we figure, because we do a lot of consulting on these areas as well, but many times there's no protocol for preheating the roaster. So we need to ensure that you have a stable setup to start with, so there's no fluctuation there. So you can always start from a very defined point and start roasting. And from there, you just have several test runs to find this specific kind of spot we call the central balance point, which might be something that is located here. So we find this by just doing a lot of many roasts and comparing the readings we have, like the colors, the solubility, and all the things we calculate. And then you can see you're getting near the point for this roaster. And we have to do this procedure for every roaster. So actually, this still consumes a lot of coffee in the first place. But when you actually have this running, this whole
Once you
setup,
got it, then
you don't have to waste any coffee anymore. You just have one sample roast, and you know exactly how to transfer this profile to the big machine. So the central balance point, the example by example, the red dot you see here, I put it in like a matrix just to explain it. So when you have the central balance point, we give it like a reference name. And from there, we can define certain stop points on the same curve. And these are different profiles already. So for this example, we have 5 different profiles. And what we do next is that we also define curves or profile with different energy level, because this is what we are all about, is the amount of energy we're giving into the bean. We call it energy transfer level. And if you do this, you see different curves. So the red dots are similar in the color and TDS, or solubility. We measure it in TDS. And you have several of these curves. And you can create as many as you want. Usually we have like 5. That's our current setup. We have 5 of those curves, and each curve has 5 stop points, which gives us a total of 25 roast profiles we can choose from all the time. So, and the next thing, how do we get into a matrix, is just like, if you just by drawing, just imagine this is kind of matrix. If you have all these points and you just turn it a little, this gives you kind of a matrix. And this matrix we can transfer, just let me just pretty quickly move over from one machine to the other. So if we have one roast profile on the one machine, it transfers pretty well to another machine. Just let me add a quick note. So this is the profile we did like for the sample roaster, and we don't end up at the same spot. We just a little off here on the machine, like the 12 kilo roaster, and we might be even off a little bit more on the 25 kilo roaster. But this can be fixed, because we know we need just an offset and can bring it back to the point where it belongs. So actually, after setting up all these things, so we have all these matrices on the different machines, we are able to just have a sample roast on the small roaster, choose a certain profile. We say, okay, some enzymatic aromas are very pronounced and we want to keep them, and we were able to bring it over to the machine because we have similar results there. It's never 100% match, but it's very close, even by the values we measure there. Yeah, that was just a rough overview of what we do. I don't know if there are any questions.
I just wanted to mention, if there's any questions, probably just go ahead, write them in the chat. we're looking forward to answer them, because when I look at this, my question is, this is just something that actually at the moment you can do, right? This is nothing that would be applicable to anybody else who would looking forward to transfer this recipe. So this is your idea and how you do it, right?
That's right. When we started, it was pretty complicated because we need all the laboratories and then just the cycle to just get the feedback of what we do. Today, we're at a point where you can just do it using like a colorette or a TDS meter and some standardized ways of brewing the coffee. That's very important because you need just to get the average color reading. So we do some kind of thieving the particles. It's a lot of preparation for the samples to be able to brew it constantly. It's a very standardized process, but with a little invest, every roaster could do this the way we do it. The only invest we have right now is just the coffee you need the first time you set up your infrastructure. So you need it for every machine, you need it. And usually we do it by buying just a reference coffee that is a very stable, high quality coffee that we roast on all these machines. And this is just the fixed point between those. It's the link. Yeah, but we're further working on things because it's not actually quite feasible just to have like test runs for all the profiles we do. It's like right now we have 25, and I have an IT background, so we're working on something like having neural networks, just finding the spots in between those profiles we have. So you don't have to roast; they will give you a best guess of what it is, and it's pretty close. But actually, it's work in progress still.
I'm very happy that you mentioned that you have the IT background, because when I looked at it, I was like, okay, me with having a language background, how do I actually translate that to what I know from roasting to what you show us right now? So this is actually, I think, a lot of roasters, what they would like to have is to just give them kind of a formula. This is always what they ask when they come for training. So isn't there some kind of a formula where you can kind of upscale or downscale the result that you get and just use it for a different machine? And of course, it's obviously not. And what I think is very important, what you say, is as soon as you want to have certain points that are always the same, of course you need to have some sort of protocol how to preheat your machine, how to have your machine being held on temperature between the single batches, like the between batch protocol. And already here it's starting that not as many people as we are hoping are doing this in really correct terms, always the same. And this is already where it starts, that we have differences in recipes, and then using different batch sizes, using different drum rotation, using different fan speeds. This is all what gives, even if you have found your recipe, an offset. And then when we talk about going from one machine to the other, and maybe not only switching machine sizes, but maybe also switching manufacturers, which gives us different drum material, different setting of the flaps inside the drum. This is all having so much impact. So it's the recipe transfer is not as easy as a lot of people would hope that it is, because there's so many things that are having an influence to that. So it's not just be done like this.
Well, if you want, you could tell your clients or our clients there is a formula. It's about 36 pages.
Oh my God. Yeah, I can do this.
Then they can decide if they want to do this. Something I want to talk about is Wolfram just showed you the grid of how they rotate the matrix and how they do under and overshoots. And from how I understand what you're doing, Wolfram, is basically you're fixing an energy level and then you're moving them up and down, which is kind of the same as me saying you're moving around those isolines. You're increasing heat and reducing airflow, which will have an impact on your thermocouple a lot more than it's going to have on the transferred heat. So they look very different, but on the physical level they are very similar.
Yeah.
Would you agree with that?
We work with the amount of energy we bring into the roaster and the mix. So many people just use or don't care. They just heat it up. But we differentiate a lot between radiation and other sources of energy, because the mix changes how the bean accepts the energy. And this is one important
absolutely.
note, is that the profile we create on the if we have them ready, they just look like this for the coffee we use as a reference coffee. All other beans will look different. So you might always think your profile is off, but actually the amount of energy that's going into the bean is the same. So that's the main idea behind of everything we do, is to be able to control the amount of energy that goes into the bean. So even if it looks different on the probe, which happens all the time if you change coffee or batch sizes.
Yeah.
Yeah, absolutely.
This is connecting to one of the questions we got in the chat. Tim is asking if the bean pile of a half batch reaches the thermocouple on a 12 kg or what is it, 25 kg machine. And here, from what I know, it's of course, first of all, it's important how old the machine is and where's the thermocouple located in the machine. So I do know that with the older machines we offered, the thermocouple was not always reached by enough beans. But even now that we have changed the position, and we can say, yes, half a batch is, of course, reaching the thermocouple, but of course you will get different reading, because the combination between product and air moving by the thermocouple will be different from half a batch to a full batch. And of course, yes, it's reaching it, and yes, you get stable values, but you have to know how to use those values in combination with the recipe that you're having.
Yeah, what you need to think about, if you reduce to a half batch, the machine is going to be able to provide a lot more energy than is needed by the batch.
Yeah.
And therefore, it's possible to transfer a lot more energy, which generally increases the reading of your temperature curve, because the air itself is hotter at that point.
Yeah, and you have less product that you can give it to, so it's going to change a lot. Yeah, true.
And actually, Wolfram and me, we talked a lot about the preheating up process and how that needs to be standardized and how to get this as good as possible. We've actually been working together with some programmers here to make our machines better in that regard. So we're trying to get better in this regard as well, because obviously it's going to be one of the most important steps to getting good results for your roaster.
Yeah, and also when just looking outside the window and seeing that we are having heavy rain now here in Emmerich, this also has an impact on when you start your roasting day. How do you heat up your machine? How much heat will stay in your machine in terms of machine body and drum material, and how does also the outside conditions, how do they change over your roasting day? And this also has an influence on how do you use your burner setting. What are you doing with all of these parameters that you can actually adjust, and what's the combination of those? Because it's not only one or the other, it's always in combination.
Yeah.
So yeah, that's also a big issue.
I think one thing to mention is that these kinds of approaches only work if you have a specific kind of setup. So if you just have roasters that are not allowing the kind of control you need, you will not be able to adapt to all of this, what we mentioned today.
True.
I usually compare it like with the simple espresso making. If you just have a machine that's not temperature stable, you can for sure temperature serve and try to find the water temperature for brewing a proper espresso. But if you have a machine that actually does this for you, it's way easier. And what we're talking about here is that you have a setup like the PROBAT roasters that are very stable from the start, give you the kind of insight of the roast machine, and then you can build on top. If don't have all of this data, you can't start this process, because it's very data-driven, it's very scientific. I'm not against science in coffee roasting at all, because many people just state it as art. To me, art starts where you just have control over everything, and then you can start being creative. But to be creative, you should know what knobs to turn, what options do you have, what you can do. So it's very important to have a very stable setting you can work in.
Yeah, you need to have a starting point, because otherwise you don't know where your creativity should start from. And then it could go in all directions, and you will never end up having this result that you're looking for, especially when you're looking for the same outcome in aroma and in the cup at the end, so that your customer will not taste a difference if it's roasted on a P12 or on a P5 or on whatever roaster. And this then is very important as well.
I think what we can strive for with science is what you said also, Wolfram, is we get close, but we're never going to hit it. And that last part, to get it exactly perfect, that's the craftsmanship. That's your experience you have to get it exactly where it needs to be, and not only somewhere close.
Yeah.
But that's the kind of service we try to provide, to get you as close as possible so that you can get the best coffee you have. But we're never going to go without some sort of craftsmanship or experience.
But it is extremely helpful, because then you're already almost there, and you just have to go like that last little step.
Yeah.
And you don't have to do it all the way. But I believe that last little bit in a lot of cases is necessary to just also give it some sort of personality, to make it that special beverage we are looking for, with that aroma that we want to have.
Yeah, probably the perfect example of this. I have all those scientific things down. I'm a horrible roaster. You never want to drink anything I roasted. It's just horrible.
Yeah, we need to combine that, and then we're gonna make it a cool coffee.
So if I want to roast, I always ask somebody else to get it right for me.
Yeah, this is where the gut feeling comes in.
Exactly.
Yeah. Well, I do have another question in the chat, which is not really related to our topic, but still I would like to answer it. There is a question from Hafiz, and he's asking to which average temperature the 25 kilo machine needs to be roasted to. And this is, of course, always depending on what's the starting point, what's your coffee, what's the amount that you want to roast. It's not only the size of the machine. So also here, of course, we could always say we down here in our showroom, we heat up the machine to approximately 210, and then we get started. But of course, also here we have a preheating protocol where we overheat a little bit, where we wait, where we give it like 40, 45 up to an hour time to just heat completely through and through. So this question cannot be really answered with on the spot. But of course, here, if there's more interest in the topic, just send me an email and we can discuss this a little bit more.
I guess that's part of your craftsmanship there.
Exactly.
To find the perfect temperature preheating protocol for your roaster.
Yeah, yeah. And then not only the roaster, but also the coffee and everything that you want to get out. So also here, it all comes together again. Yeah. Well, as far as I see it, there's no further questions in the chat. No, here it's really quiet, and also LinkedIn is quite quiet. So yeah, the explanations must have been quite well, so people don't have questions. That's
it
pretty
just
cool.
went over everybody's head.
Yep, or this could also probably be one thing, yes. But I think also here, Wolfram, you are open if there's questions coming in, that we can all the time get back. Cool, very cool.
So if you're ever in the neighborhood of Frankfurt, just stop by. Backyard Coffee, great roastery. Sure, Wolfram will have a talk with you, and you can have some great coffee.
Yeah.
Perfect.
Well,
you're welcome anytime. Thank you.
Thank you. Thanks for sharing all the knowledge. Thanks for showing us all the crazy numbers and curves and data. So I'm a little bit confused now, but I'm going to put it all back into the picture, and I know where to turn to. So it was very interesting. Thanks, Wolfram, for being here, for being our guest for this session.
Thank you very much.
And Sebastian, as always, thank you as well. It was really cool, and looking forward to do some more of that.
We will.
Yeah, for sure. Well, see you all at the next session, and take care. Goodbye.
Thank you. Bye-bye.